Alright, I want to go on to section 10.14, and I want to talk about volume of pyramids. So, pyramids are, typically volume is easier than surface area, but pyramids can be a little bit tricky, and I want to explain why. First, let's talk about how we can get to the volume of a pyramid. So let's look at a shape that we kind of know and love, our cube here, and let's look at how it compares to a pyramid. What I can actually do is I can put a pyramid inside of this cube. So if I put a center spot inside of where this would be, I can actually draw out my pyramid inside. And you can see how that it kind of fits within a little bit. I probably should have done my pyramid in a different color. It would have popped a little bit better. But you can see that it's kind of within the inside. And my volume of a cube is really easy, if you recall. If we have a length, we have a width, and we have a height, the volume of a cube is simply length times width times height. But with our pyramid, if you look, there's a lot of empty space relative to the cube, and there's a lot missing. And there's an interesting thing that happens when you turn a pyramid inside of a cube like this. The volume of the pyramid, and there's a really cool example you can do with some manipulatives, where if you take a cube or a kind of like a cup that is a cube, and you kind of fill it with kind of water on the inside, if that makes sense. And this is colored on the outside. And you have a pyramid that fits exactly inside. And this is also open, and it's filled with water. Now I know I left a little bit of space, but pretend it's totally filled. What's really interesting is that it takes exactly 3 fills for this cube to make it entirely filled. So if I fill this cone or this pyramid cup up with water, and I dump it into the cube, I dump it into the cube again, and I dump it into the cube a third time, it will be exactly filled to the top. And that is kind of interesting. So the space inside of this cube means that this pyramid takes up exactly 1/3 of the total space in the cube. And that lends it really easy for us to create a formula to find the volume of our pyramid. In this case, if I was going to make the volume of a cube, I could write it like this. I could write the volume, or the area of the base, which is what my capital B always means, times the height, which would work for my cube because it's really the area of the square on the bottom times the height going up. But in this case, we want the volume of our pyramid. What's also interesting, and this works for any kind of pyramid, no matter the base at the bottom, but we're going to take the base of the pyramid, multiply it by the height, but we only want 1/3 of that total. So our formula for the volume of a pyramid looks like this: 1/3 of base times height. Now the trick, or the problem that can come in here, is related to this B right here, because this B can change. For example, if I am working with a triangular pyramid, recall that those kind of look like this. Let me see if I can draw one. No promises. Notice they have a triangle on the base. So in this case, our formula would quickly go to this: 1/3 of the base, which the area of the base in a triangle is 1/2 base times height, times the big height. Where if we were looking at a rectangular pyramid, which would look like this. Let's see if I can draw it. I think I'm a little off, but that's okay. Kind of. Well, that kind of works. But when I'm building my volume formula, it's going to be equal to 1/3 base, which in this case is length times width, times my big height. So we need to be able to adapt and change based on what we're doing. And even if you have a square pyramid, it's going to be slightly different, because the base of a square, remember, is s squared. And that formula looks like this. My square pyramid looks like terrible pyramid, but the formula will still work. My pyramid here is going to be 1/3. My base is going to be side squared times height. So it can be tricky to pick which of these we need to use in order to solve for our volume. Now, if you feel like you kind of understand and are able to pick, go ahead and do it. I'm going to do an example using one of these formulas for you to kind of see. I don't anticipate it's going to be that difficult, because I think we all know how to plug into a formula at this point. But let's take a look at a quick example. I'll do number 1 on the homework, which we're not going to do anyway. We have a square pyramid with a base of 6 and a height of 9. Base of 6 feet and a big height of 9 feet. I'm going to use my square pyramid formula, which, if you recall, is 1/3 s squared times big height. 1/3, volume of 1/3 equals s squared times big H. 1/3 times 6 squared times 9. Remember, I have to do my squaring first. 1/3 times 36 times 9. I'm going to do my 1/3 times 9. So I have 36 times 3. And 36 times 3 is 108. And of course I should have put my units in there, but because I am solving for volume, I will be in feet cubed. Make sense? That's example 1. I hope that works. I'll do one more, and I'm going to do the trickier one, the triangle pyramid. I'll do number 9. Base length of 5 inch. Base length of 5 inch. Base height of 4 inch. And a pyramid height of 6 inch. Okay, in this case, my volume is going to be, looking back at my triangular pyramid, 1/3 times 1/2 base times height. 1/3 times 1/2 base times height times big height equals 1/3 times 1/2 times my base of 5 times my base height times 4 times 6, because I'm putting in all the numbers that I know. Now I just need to multiply it out. 5 times 4 is 20. 20 times 6 is 120. 120 times 1/2. I guess I can just write this. I'll just go 1/3 times 1/2 times 120. 1/3 times 1/2. This should be 1/6 times 120. Which is really just 120 divided by 6, right? Because I can multiply like that. 120 over 6. My volume is 20, and I'm in inches. Inches cubed. Okay, good luck.